Alright students, welcome back to another episode of Math with Mr. Young. Today we're going to be working with 4.4 solving percent problems. Our standard is 6th grade number since A, and our objective is that we will be able to find a percent of a quantity and solve percent problems. Our mathematical literacy, we have equation, ratio table, model, double number line, and area. Alright, so for 4.4, solving percent problems, our success criteria is that by the end of this lesson, you will be able to represent percents of numbers using an equation, a ratio table, and a model. We'll talk more about those vocabulary words as we go along. You'll also be able to find percents of numbers, kind of like if you were to go to a restaurant, you got to find out how much you're going to tip the waiter or waitress, okay, that kind of stuff. And also, you'll be able to find the whole of a number when we're given a part and then also the percent. All right, let's get started. All right, so with mathematical literacy, we have equation, we have mathematical models, area, ratio table, and double number line. Now let's start with an equation. So an equation says that two things are equal. In this example, we have 7 plus 2 is equivalent to 10 minus 1. Now, on the left side of the equivalent sign or the equal sign, 7 plus 2 is 9. And on the right side, we have 10 minus 1, it's 9. So 9 is equivalent to 9. Now, an equation is also, as long as we have an equal sign, then whatever number sentence there is would be an equation. For example, we have 2 plus 3. So, the differences between an expression and an equation is that an expression has no equal sign. 2 plus 3 equals 5. 2 plus 3 equals 5. Now, again, this is technically an equation because it has an equal sign. An expression has no equal sign, which is why it's an expression, okay? Now, a ratio table here is a list of equivalent ratios, equal ratios that help us understand the relationships of numbers and ratios. So we have two different ratios here. We have the part to the whole. So part to the whole. So in this sense, we have 60 over 100, 30 over 50, and 90 over 150. So if you look at these things, look for patterns. I'm going to zoom in just a bit. Look for patterns. So 60 over 100, if we divide 60 by 2, we get 30. And if we divide 100 by 2, we get 50. And these would be the equivalent ratios. And then how do we get from 30 to 90? Well, we multiply 30 times 3 to get 90. And we also do that to the denominator. 50 times 3 equals 150. Again, all three are equivalent ratios. So 60 parts to the 100 whole is equivalent to 30 to 50, and that's equivalent to 90 to 150. Again, ratio tables is a list of equivalent ratios that help us understand the relationships of numbers and ratios. Zooming back out. With mathematical models, models, we think of diagrams, we think of pictures, and models is something that we make, it's something that is made to look like another thing. In this case, we have a three-dimensional box, in other words, a cube. So one dimension is your length, another dimension is your width, and your other dimension is your height. So again, you have your length, which is your x-axis, okay? Your height, which is your y-axis, and your width, the depth, is your z-axis. So this is one-dimensional, this is one-dimensional, and this is one-dimensional. So your length, your height, and your width are all one-dimensional. 1 plus 1 plus 1 equals 3 dimensions. So this is a three-dimensional object. In other words, it's a three-dimensional cube, okay? And again, we don't have an actual box in front of us, but we are showing this because it's something that is made to look like another thing. So in this case, it's a box. Again, mathematical models is just basically, think of diagrams, think of pictures, okay? Now, area down here, area is the space inside a two-dimensional object. So in this case, if I have a room let's say maybe a doghouse. Let's say a doghouse, and we're looking from the top down. Okay, so we do have a length. Okay, and then we also have a width. Again, remember we're looking from the top down. Okay, and then if we look here, maybe here's like the entryway for the doghouse, and then you're looking from the top down. So again, the area is the amount of space inside. So if we're just looking at the floor of the doghouse, how much space is in here? So again, to find the area, you multiply the length times the width, and then you'll find the area. You'll find the whole space measurement inside that doghouse, the doghouse floor. Okay. Now lastly, we have the double number line, and a double number line shows quantities on its own number line, which corresponds to pairs of values that are lined up. So in other words, we have two x-axes. We have the first x-axis, and then we have the second x-axis. Again, this is your horizontal number line. Now, with that being said, the first number line is all about percents. Okay, for the first x-axis, it's all about percents. So we have 0%, 25%, 50%, 75%, and 100%. The bottom, or the second x-axis, we have number. We have 0, 10, 20, 30, and 40. So that means that we're comparing, showing the quantities on these two different number lines. So right across, we have the number 40. Okay, so 40 is going to be 100%. So let's say, what is 50% of 40? Well, 50% of 40, in other words, half of 40 is 20. What is 25% of 40? Well, 25% of 40 is 10. 75% of 40 is 30. Okay, so again, it's all about patterns, and these are technically equivalent ratios as well, because we're comparing two different quantities. All right, so there you go for mathematical literacy, and let's go ahead and move on. Now, when we find the percent of a number, we have the total number. So the total here is the number 40. So we want to know what is 25% of 40. So if 40 here is 100%, okay, and we create and model a double number line. Oops, went a little too far there. Here's 0, there's 40, so this is 0%. Half of 40 is going to be 20, so that's 50%. Okay, so we're modeling here, modeling this problem right here, 25% of 40. So again, what is half of 20? Well, half of 20 is going to be 10. Half of 50 is 25. And in between 150 will be 75. And in between 20 and 40 is 30. So we have this double number line, okay? And again, 40 is a total, so 100% is 40. Excuse my dog. So again, we're comparing two different numbers. So the first one is all about percentages, and the bottom number is just a number. So we're comparing percents to numbers as a ratio. And again, so again, here's 40, 100%. 25% of 40 is 10. So we're going to equal 10. So that's what we do when we model it using a double number line. However, I do have some steps here for you. The first step, what we can do is write the percent as a fraction, and then we multiply and then simplify. I'm going to rewrite the original problem here, down here, 25% of 40. Now, really quickly, the word of tells you to multiply. So what that means is we're going to convert 25% into a fraction. So 25% as a fraction is going to be 1/4. Of means to multiply, and then the whole number 40. Okay, so again, right here we want to make the whole number into a fraction simply by putting a 1 underneath of it. And Now we just multiply fractions. We learned that a while back. So again, you're going to multiply your numerators, 1 times 40, and multiply your denominators, 4 times 1. So we're going to multiply these two factors, 1 and 40, and we're going to equal the product 40. So 1 times 40 equals the product 40. And then 4 times 1 is going to equal 4. So now we have this improper fraction, 40 over 4. So that means you divide. So 40, your numerator is your dividend, and for your denominator is your divisor. How many times can 4 go into 40? Well, 4 can go into 40 10 times. 4 times 10 is 40. 40 take away 40 is 0, and your quotient is 10. So this is going to be equaling to 10. So again, 25% of 40 is 10. All right, so hopefully that makes sense to you, and don't worry, we're going to go over more examples as we move forward. All right, so with this next example, we're going to find the percent of a number using a ratio table. So the problem is we want to find out what is 60% of 150, and we want to know what number that is. So 60% of 150 is what number? Now again, you always want to do, let's go ahead and set this up as a fraction. So 60 over 100. Now of tells you to multiply 150. The word is tells you that's an equal sign. What number? Well, we'll just say P for the product. So again, 60% of 150 is what number? So we put a P, the variable P for the unknown number. Okay, but I wanted us to use a ratio table. So again, we have 60 over 100. So again, we have a part to a whole. Okay, part to whole, 60 over 100, and we want to get to 150. Okay, so we want to know what is, so 60% of 150 is what number? Well, let's go ahead and look at patterns here. So let's say half of 100. Half of 100 is 50, and then 50 times 3 would be 150. So what we did to the bottom, we're going to do to the top. So half of 60 is going to be 30, and then 30 times 3 is going to be 90. So again, 60% of 150 is what number? We're saying that P is going to equal 90. The answer is 90. So 60% of 150 is 90. So 60% of 150 is 90. That is our answer. And to prove that to you guys, 60 over 100 times 150. So we're going to make 150 into a fraction by putting a 1 under it. Now we have 60 times 150. So 60 times 150, multiply numerators, and 100 times 1. All right, equals P, the product. So again, 100 times 1 is going to be 100. 60 times 150. So check this out. 6 times 15 is going to be 90. And then add your 2 zeros. So we have 9,000 divided by 100. So if we knock these 2 zeros off, cancel them, we're looking at 900 divided by 10. So 900 divided by 10. 10 can go into 900 90 times. 10 times 90 is 900. 900 take away 900 is 0. So again, 90 is going to equal the product. So in this case, again, 60% of 150 is 90. Okay, so we proved that by basically multiplying here and then using a ratio table there. Okay, so for this next problem, we're going to find the whole. The whole meaning the total. So what we mean is the total. Okay, that's what we mean by the whole. Now here's the situation or the statement. 50% of what number is 48? Well, check this out. So we have percent and we have a number. Okay, so we're saying that 50% of what number is 48? So that means, you have 48 here. So again, 0% would be 0. Okay, and this double number line here. And if we kept going, not the best, but what would be 100% is what we're asking. So we're trying to find the whole here. What would be 100%? Well, if 48 is half of that number, we just double 48. So what's 48 times 2? 48 times 2. 2 times 8 is 16. 4 times 2 is 8 plus 1 is 9. So there you go. 100% is going to be 96. So half of 96, so 50% of 96 is going to be 48. Half of 96 is 48 is what we're saying. All right, so we showed you with a double number line. Let's go ahead and solve this way. So again, 50% of what number is 48? So if we have 50% here, what does 50% look like as a fraction? Well, it's just going to be 1 over 2. That is half. Okay, so half is 50%. Of, remember, of in multiplication means to multiply. What number? We're going to have a variable. Again, we're going to look for the whole. Okay, so we're going to look for the whole. So we'll put W. Is means to just put the equal sign there, and then 48. So here's our number sentence. Here's our equation. Again, as long as we have an equal sign in this word or this number problem or a number sentence, it's going to be an equation. So then we just solve. A fraction times a unknown variable or unknown value, which is our variable W. We're trying to find a whole. The word whole starts with a W, so I'm just using that letter there, is 48. So what is the opposite? What is the inverse operation? What is the multiplicative inverse of multiplication? Well, the opposite is what I'm saying. What is the opposite of multiplication? Well, the opposite of multiplication is division. So what we're going to do is we're going to divide 48 divided by 50%. In other words, that's going to be 48 divided by half. Okay. And then, of course, you make this into a whole or a fraction. This whole number 48 into a fraction by putting a 1 underneath of it. Rewrite it, 48 over 1. Change the sign from division to multiplication. Reciprocate the 1/2. So this is going to be 2 over 1. So 48 times 2 is 96 over 1, which is reality, just 96. So again, there you go. So we have half. We're going to check now. And we're going to see if it matches. So half times 96. So we're saying that W equals 96. The whole is 96 is what we're saying. So half is going to be 0.50. Okay. Times 96. We should get 48. Boom. So that's going to be 48. So 48 is equivalent to 48. So it checks. All right, here we go with another example. So we're going to find the whole using a ratio table. We're going to write a fraction. So 120 over 100. So we're changing a percent into a fraction. Remember, your denominator has to be 100. So in this case, we have a part to a whole. Okay. So we want to get to 72. Okay. Now, if I look at this, I'm trying to do some numbers in my head. I do know that if I were to divide 120 by 20, I would get 6. And if I divide 100 by 20, I would get 5. Okay. So I'm just reducing by 20. So I have 6 to 5. And then how do I get from 6 to 72? Well, if I multiply 6 times 12, that does equal 72. And 5 times 12 is going to be 60. All right, with this last example, we're gonna solve a percent problem. So let's listen to this situation. So the width of a rectangular room is 80% of its length. So we don't know what the width is. Okay, so the width we have no idea, but we do know that the length is 15 feet. Of this looks like a room, looks like a couch, and a TV. So the width of a rectangular room is 80% of its length. What is the area of the room? Now remember, the area is basically like this space inside. So in this case, look at a floor. How much area does this room cover? Okay, all the space inside. So, and again, the area, we multiply the length times the width. But we do know that the area, we do know the length of the, we do know the measurement of the length is 15 feet times, we don't know what the width is. So we got to find and solve for W, okay? So again, the width of this rectangular room is 80% of its length. So the length is 15 feet. So we're gonna solve for W. We don't know what the width is, but we know that the width of the rectangular room is 80% of its length, 15 feet. Okay. And then all we do here, guys, we just solve. So 80% to a fraction is going to be 80 over 100 times 15. Make that whole number 15 into a fraction by putting a 1 underneath of it. Okay. And then we just multiply. You just multiply 15 times 80. Okay, so 15 times 80 would be, let's see, 15 times, let's see here, 15 times 8. 15 times 8 would be 120. And then we just add that 0 after that. And of course, 100 times 1 is 100. So if you look at these, there's two zeros that I can cancel out. So reality is I'm going to be basically dividing 120 by 10. So, oh, there's another zeros I can cross out. Boom. So reality is like you have 12 over 1. So 12 over 1 is just going to be 12. The width is going to be 12. So that 12 here, 12 feet, that equals W. So the area is going to equal 15 feet times 12 feet. Okay. And 15 feet times 12 feet is going to be 180 feet squared. Boom. So there you go. Now again, you got to remember the formula for the area is going to be length times width. But because we have an unknown value in this model or diagram or illustration, this picture here of the living room, we do know that the length is 15 feet, but the width, we don't know that value, which is why I put W for the variable. So 80% of 15 feet is going to equal the width. So 80 over 100 times 15 over 1 equals the width. Now 80 times 15 is 1,200. 100 times 1 is going to be 100, but these zeros just canceled out. So in reality, we have 12 over 1 equals W. Okay, 12 over 1 is just a whole number 12. So we know that the width is 12 feet. And then to multiply the area, length times the width, so 15 times 12 is going to be 180 feet squared. So what is the area of the room? The area of the room is 180 feet squared, or 180 square feet. All right, there you go. And that's how you solve percent problems. All right. So have fun with it. Listen. Again, your first step that you want to always do is to write the percentages as a fraction or you could even write them as a decimal if you want to. And then the next step would be to multiply and then simplify. And if you need to, sometimes, especially if you're finding a whole, then you would have to divide, but you should be good to go. Now for 4.4, solving percent problems, by now you should be able to represent percents of numbers using an equation, a ratio table, and a model. You should also by now be able to find percents of numbers and also be able to find the whole when we're given the part and the percent. All right, so pay attention. We're going to go over this in class again. Get out your scrap papers, your pencils ready, and let's go ahead and get started.